Pert, project evaluation and review technique. It helps us to find the uncertainty of the project. Now let's look at the university question. This is the question where we are given the data and we are asked to construct the project network, find the duration, time and variance, critical path, expected project completion time and the probability of completing on or before 35 weeks. So let's start with constructing the project network. For constructing the project network, we have to find the number of activities who does not have an immediate predecessors. Here we have 3 activities who don't have immediate predecessors. So first I'll start with activity number 1. And since A, B and C does not have immediate predecessors, I'm connecting this to the number 1. So number 2 will be activity A. 3 will be activity B. Be activity C. For activity D, its immediate predecessor will be A. So with A as an immediate predecessor, I am drawing activity D. Now for E, the immediate predecessor is A. But this E along with G acts as an immediate predecessor for activity J. So I should make sure that both E and G are together. Since I already don't have activity G, for now I don't have any issues. So I am drawing the activity E with its immediate predecessor as A. So from A, I am drawing activity E. Similarly for F, it does not act as an immediate predecessor for any other activity, but its immediate predecessor is A. So I am drawing F. For G, its immediate predecessor are B and C. Since B and C are 2 independent activities, I am going to make them as one by using a dummy variable. I can connect them using a dotted lines and name it as dummy variable 1. So for now, B and C. So activity number 3 represents both B and C, which acts as an immediate predecessor for G. But G should stay along with E. Since already 6 represents activity E, I am joining it to 6. So this will be G. For H, immediate predecessor is C. So C is here and its immediate predecessor is H. And for D will be the immediate predecessor for activity I. And J will be the immediate activity with an immediate predecessor of E and J. So this will be the E and J activity and I am joining it here. So now I have constructed the project network. In the duration, they have specified 3 characters A, M and B. A specifies the optimistic time, B is the pessimistic time and M is the most likely time. So for the next question, they have asked us to find the expected duration and variance of each activity. So expected duration is nothing but the mean. Mean is represented as mu. Means formula will be mu is equals to A plus 4 times of M plus B by 6. So for calculating the mean for activity A, it will be 4. Plus 4 into 4 will be 16. So 16 plus 4 will be 20. 20 plus 10 will be 30 and 30 divided by 6 will be 5. Similarly, you can calculate the mean for all the other activities. It is 3, 6, 4, 2, 5, 3, 4, 3 and 7. Now going to the variance, which is the variance of each activity, that is nothing but sigma square. Its formula is B minus A by 6 the whole square. Here B is the pessimistic time and A is the optimistic time. Now for calculating the variance for activity A, it will be 10 minus 4 will be 6. 6 divided by 6 is 1. 1 square is 1. Similarly, calculate the variance for all the other activities, which is 1.78, 4, 1.11, 1.78, 1.78, 0, 1 and 0.11. So now I have calculated the expected duration and variance of each activity. Now let's go to the third question. It is used to find the critical path. Now for finding the critical path, we need two components, earliest start time and latest completion time. Earliest start time formula will be maximum of, so first I am going to calculate the earliest start time of one activity, which I am representing it as j. So it will be the maximum of earliest start time of the previous activity plus distance between these two activities I and j. Similarly, latest completion time of the activity j will be minimum of latest completion time of the previous activity minus its distances between the two activities, so dij. So before calculating the earliest start time and latest completion time, I have to specify the distance between two activities. That will be nothing but the mean, which I have calculated. So for activity A, mean is 5. So I am specifying it as here as 5. For B it is 3. For C it is 6. For D it is 4. For E it is 2. For F it is 5. For G it is 3. For H it is 4. For I it is 3. And for J it is 7. So to calculate the earliest start time and latest completion time, I am drawing a box for each activity. The below one represents the earliest start time and the latest one represents the latest completion time. Since initially we don't have any activities prior to this, I am initializing it both to 0. Now let's start with calculating the earliest start time. For earliest start time for activity number 2 will be like earliest start time of the prior one I, which is 0, plus the distance. So this is the distance 5. So 5 plus 0 will be 5. Since here we have B and C as represented as one activity, we should take the maximum of those two. The maximum should be represented. For B it will be 3 plus 0, 3. But for C it is 6 plus 0, 6. Since 6 is the highest, then since 6 is greater than 3, I am representing both the earliest start time as 6. Since it is connected by a dummy variable D1. Now going with D, for D, it's 4 plus 5, it is 9. For 6, it has two activities coming to it, from 2 and from 3. We have to calculate both these things and we have to find the greater value. This will be 5 plus 7. 5 plus 2 will be 7 and 6 plus 3 will be 9. Since 6 plus 3 is greater, I am representing it here as 9. For 7, it has numbers coming from 3 numbers, 2, 6 and 5. So 5 plus 5 will be 10, 7 plus 9 will be 16 and 9 plus 3 will be 12. 7 plus 9 is greater, so I am representing here as 16. So this is the last activity. So I am initializing my latest completion time as the earliest start one. Earliest start time and the latest completion time of the last activity both will be same. Now after completing number 7, again have to go to activity number 6 for calculating its latest completion time. It will be the minimum value and subtracting of the latest completion time minus its distance. So for activity number 6, it points out only to one activity. So 7 minus 16 will be nothing but 9. For fifth activity, it has on pointing to only one activity, that is 7. So we have the 16 and 3. 16 minus 3 will be 13. Pointing into the 4 now. 4 minus 16 will be 12. Similarly, since B and D already have a same together, B already points out to 9 minus 3, 6. Since the minimum value is 6 compared to this 12, I am representing both as 6 because we have to find only the minimum value for the latest completion time. And going for the second one, since second one points to 3 activities, 5, 6 and 7, I have to calculate all the three and find out the minimum value. 13 minus 4 will be 9 and 2 minus 9 will be 7 and 5 minus 16 will be 11. So the minimum value will be 7. So I am pointing out here as 7. So I have calculated the latest completion time and the earliest start time for all the activities. Now the critical path will be formed where the latest start time and the earliest completion time will be equal. Here starting with activity number 1, then we have pointing to number 4, 0, 0, 6, 6. So this is equal. Then these two are equal. Then after activity number 3 to 6, this is equal. Then 6 to 7, because 9, 9 and 16, 16, this is equal. So my critical path will be C, D1, that will be dummy variable 1, G and J. This will be the critical path. Now we have to calculate the expected project completion time. Expected project completion time will be nothing but the values, the mean value taken from the critical path. That will be 6 plus 3 plus 7, which is nothing but 16. So this will be represented as a mu value. Now let's go to the fourth question. We have found the critical path and the expected project completion time. Now let's go to the fourth question. Probability of completing the project on or before 35 weeks. So for calculating the probability value, the formula will be probability of x minus mu by sigma, which is less than or equal to 35. So this is nothing but z. So probability of z less than or equal to 35. Now we have to find all these variables x, mu and sigma. X is nothing but this 35. Mu, sigma we have to calculate, and mu is the value which we have already calculated, that is 16. So mu is 16. Now we have to find the value for sigma. Sigma will be nothing but 4 plus 1.78 plus 0.11 sigma square. This will be nothing but 5.89. I got all these values from the critical path. Since my critical path is C, G and J, from C it is 4, from G it is 1.78 and from J it is 0.11. I have taken all those values. That is nothing but the sum of the variance of the critical activities. Sum of variance of the critical activities. Since I need to find only sigma, sigma will be root of 5.89, which is nothing but 2.427. So I can represent this as P of x minus mu by sigma, which is nothing but z, is less than or equal to 35 minus 16 divided by 2.427. Since this is z, it is represented as z, is less than or equal to, by solving it you will get a value of 7.82. From the normal distribution table we will get this value, that is 0.999. So this will be the probability of completing on or before 35 weeks. Thank you.